Hello everybody, I'm here with some calculus problems. You might be wondering why I'm doing this randomly. I figured it'd just be fun to do so. Anyway, these are just going to be some basic problems in calculus relating to derivatives, limits, and integrals. So, I think we'll maybe have a fun time with this one. So let's get started on our first problem here. The limit x goes to 2, x squared minus 4 over x minus 2. Now obviously we cannot take the limit because if we were to plug in 2, we would have a 0 in the denominator. And we cannot have a 0 in the denominator, otherwise you'd be dividing by 0, which is undefined. Now, let's begin. Now we can start by distributing, right? Or not distributing, my bad, I meant factor, where we can do this, and then we have x minus 2. Now that we've done that, we can now cross both of these out, and then we are left with x as the limit goes to 2, x plus 2, then we can plug it in, and we are left with a final answer of 4. Now, that wasn't so bad, was it? Let's move on to the next problem. Alright then, let's move on to our next two set of problems. So we have f of x equals 10,000, and then we have to find a derivative of that function, and then find out what it equals when I plug in 2. And then, so let's just get started. So the derivative of this actually is going to be 0, because any constant, when you're trying to find the derivative of a function, will always equal 0. Now, funnily enough, because there is no x to really plug in here, even if we have 2, it'll still equal 0. So, that one was a pretty easy one. But let's get started on the next one. So, we have g of x equals 5x plus 3. So then we are trying to figure out what is this function, the derivative of this function at 6 multiplied by 0.2. And what does that equal? Well, first off, we have to find a derivative of our function first. So, we can obviously use the power rule, which is where essentially we subtract by 1. And we're essentially just left with 5, because if you have anything at the 0 power, it would be 1. So, yeah. And then we have a plus 0, because again, this is another constant, so we don't really have to worry about that. So essentially, g to the x, the derivative of the x is equal to 5. Now, even if we were to even put 6 in this, it would still equal 5. So now we plug it into the actual problem, which is 5 multiplied by 0.2. And if we do some basic arithmetic, this will just be 1. Not so bad, right? But we'll move on to something that's a little bit more complex when it comes to derivatives. Alright, so here is our next problem. So we have hx equals 5x in parentheses 2x plus 3. And we are trying to figure out what is the derivative of this function and what does it equal at negative 0.5. Let's begin. So, there are two ways you can really do this. I'm going to show you the product rule way. So, this is where you take the original function, plug it in, and then you take the derivative of the other multiple factor. So, in this case, it would be 2. So, like this, and then we do a plus here, and then we do the opposite way around, where we take the derivative of this, which would be 5, and then just plug in the term like this. Now, let's just start simplifying all of this. Now, look at this. Now we combine like terms. We were left with 20x plus 15. But there's another way you can do this, which you might find a little bit more easier. What you can do this is just distribute both of these like this. So you'll be left with a equation like this. Now, you might find it to be a little bit more easier to take the derivative like this. So, let's do it right now. So we can use the power rule again, where we now multiply by 2, and minus 1, so then we are left with x, and then, oh, I almost forgot to put an x there, my apologies for that. And then we can use the power rule again, and we will just be left with 15, just like that. And there you go. As you can see, there's two ways to really do this, but we end up with the same, like terms and numbers and stuff like that. It's up to you which you find a little bit more easier. You might find this a little bit more easier, or if you just want to go straight into the product rule because you find that a lot more easier, it's really up to you. As long as you do the math correctly, that's all that matters. Now, let us plug in our negative 0.5 into the x, so we will have 10 minus 5 plus 15. So now we will be left with negative 10 plus 15. So our final answer will be 5. All right. So here's our next problem, which deals with an integral. So you have the integral of x to the negative second power dx, and we're trying to determine what does g equal when it's negative 1, and we also have a bit of extra information when it comes to g 1/2 equals 1. This is a very useful piece of information, you'll see why. But first off, let's do the power rule of when it comes to integrals. So you always will add plus 1 to the exponent of an integral. So this will be negative 1, and then you would have the inverse of that, which when you bring over negative 1, so it would be 1 over negative 1, which essentially is just negative 1, but I'm just going to leave it at there. However, there's one more thing we need to keep track of, and that is plus c, the constant of integration. You must never forget this ever, because if you do, some of your calculus teachers might not exactly be happy about it. Essentially, it's just because, let's say you have a function like 5x plus 3, like the previous questions before, and let's say you try to integrate 5. Well, you don't actually, if you're going reverse, you won't really actually know what constant was really removed from there. So you don't even know if it's 1, 5, 0, a million, negative 5. You wouldn't really ever know. So this is why we always add that plus c, the constant of integration. So let's get started on trying to figure out what to do. So obviously we cannot just plug negative 1 immediately into this because we have to worry about the constant of integration. However, because we know that g of 1/2 equals 1, here's what we can do. By the way, I'm going to rewrite this because I think it will be a little bit more easier. So we have negative 1 over x. I think this is a lot more easier to really recognize. So then we have plus c equals g of x. Now we're ready to rewrite this. So now we have 1 equals negative 1, and then we put in 1/2, right here, and then we do plus c. Now we're just trying to figure out what c is. So let's just do some, algebra and all that good stuff. So negative 2 plus c, and that means that 3 is equal to c. Now that we know our constant of integration, now we can finally plug in negative 1 for our x here. So let's just determine what g negative 1 is now. So negative 1 over negative 1 plus 3, and our answer will be 1 plus, oh, not 1 plus 4, sorry about that. 1 plus 3, and our final answer will be 4. Not too bad for an integration problem. A little bit tricky since there's a lot of negatives going on here, and you do have to, do this little extra step before you can actually get into it, but, you know, nothing too crazy, I'd imagine. Hopefully you were able to follow along with that, and now it's time to go along to our next question. It's time for another limit question. Now this question can be a little intimidating to you, because there is a fraction and a fraction, but let's read it out. So the limit is x is approaching 0, and obviously we cannot plug in 0 immediately because there's if we plug in 0, we would have just a 0 in the denominator, and that would have lead to an undefined answer. So what do we do? Well, let's try and get rid of this fraction right here. And how we can do that is by multiplying like this. Now, we can get rid of this fraction, but we still have to, consider how all the other terms are affected. So we will have actually, let me not write that first. I still have to make sure to consider that this is still here. So the limit is x is going to 0, and we have 1, or x plus 1 minus 1. This is just because these cancel each other out, and we're just left with the negative 1 over x plus 1. Now, let's simplify this a little bit, and we are left with x over x plus 1. Now we can get rid of both of these x's, and we are left with 1 over x plus 1. So now we can finally plug in 0. We can plug in 0 for x, and we will get an answer of 1, which is really nice. Nice answer right there. I will say there's quite a couple of 1s in this, actually. I did not really expect that. Let's move on to another type of limit question. Now, this one deals with some trigonometry, and, well, we need to actually know a property before we understand what to do with this. So, if sine of x over x, I should also include that it's the limit of sine over x equals 1. Now, how can we have this match up with that? Well, we can multiply by 3. Of course, not exactly 3, as we're technically multiplying by 1, but you'll see what I mean. So, now we have 3 sine 3x over 3x. Now, how can we get rid of this 3? Here's how we can do it. Just put the 3 outside of the limit like this, and we are left with sine 3x over 3x. And then we can finally put in our limit since we have able to match this. So now we have 3, 1, and that is just 3. As long as you know this little property right here, it's not too bad. It can get a little bit more complicated, especially if, maybe this is like 2 right here, and then you have to get some sort of fraction answer, but I think getting this should get you a basic gist of how to deal with these types of problems that use this type of limit property. Alright, here's our next problem that deals with derivatives. It is find the following critical numbers of the function. F of x equals x squared minus 12x. So, what is a critical number? A critical number is when your derivative equals 0, or if your derivative is undefined. So, let's get started. So, we can take the derivative of this quite easily. We use the power rules, so we multiply by 2, subtract the exponent by 1, and then we do the same here. minus 12. Simple enough. So then we set this equal to 0. So just solve this real quick. Let's do some algebra, and bam. X equals 6, and that is your only critical point in the function. There's no way how this function or its derivative can really be undefined, so you don't really have to worry about this. And there's really only one critical number, so this is just simply your answer right here. So, let's get started. Find the following critical numbers of the function. So, let's just take the derivative of this. So we have the power rule. So we multiply by 3, which is just actually going to be 1. So we don't really need to write down 1. And then minus 1. So that is x squared. And then we do the same thing. Multiply by 1, then reduce the exponent by 1. So that just leaves us with 4. Now, we can set the equation equal to 0. So now we have x squared minus 4. And then we have x squared equals 4. So then we take the square root of both of these, and we are left with x equals plus or minus 2. Remember, there are two critical numbers. Remember that, whenever you do a square root like this, it can be plus or minus, just so make sure you include both of your answers right there. Otherwise, you might be missing out on a potential critical number. This is really important too, because if the question asks you to find critical numbers and then asks you to also graph the or list out the intervals of increasing and decreasing, you might miss an entire interval where the function may be increasing or not decreasing on. That's a little bit more complex, and that's also a lot more in-depth of how to use critical numbers in terms of graphing. These problems don't really go that far, but hopefully you still learned something from that. And that's really all the questions that I've done so far. Hopefully you've enjoyed me completing a couple of these calc problems. They're very introductory, but I'm sure that maybe if you wanted a little refresher, maybe it was just a little fun to see some calculus in action, then hey, glad you enjoyed it, at least if you got to this point. And yeah, there totally is no connection between any of this. I guess there's not really anything else to say for a mild-mannered man that I am, so hopefully I'll see you another day.